case Gwen does not make it all the way to this meeting, then we'll still be able to get her input. So thank you, Fahim. Fahim is the NIF Standard, I guess, maintainer, creator. He is our ontologist on the NIF. He has been working very hard to try and understand these concepts of modularization and how it actually works in practice. And he has done a fabulous job combining this relatively loose lexicon that we try to maintain over at the Neural.
All right, thank you, Anita. So, like, I just have these slides about NIF standard and NIF, and about like how we involve communities. So my presentation is gonna be about half an hour at most, and then the rest of the time we'll we'll talk about the idea of harmonization and what exactly we're trying to do in terms of these mental process ontologies. So we start with the idea of NIF standard, and so it's a the idea of neuroscience information framework first. So the idea is that it is a project between UCSD and George Mason, and also Harvard MBA, and we are supported by an blueprint and is dedicated to confront the difficulty locating and searching across the diverse array of resources that we have over the web. And we are also charged with developing tools and strategies for creating resources that can be integrated across neuroscience domains. And the end product is basically the semantic search engine and a knowledge discovery portal, which has that describes neuroscience resources and provides simultaneous access to multiple types of information, organized by various relevant categories. So there are like when it comes to searching multiple information sources, we have ways we do that. So the first one is NIF registry, which is a category over 4,500. That includes databases, tools, materials, and services, and they're categorized according to the NIF resource module, or and annotated with words derived from the other NIF modules. And the second source of information is the NIF Data Federation, which is deep access to the contents of over 150 databases. We have NIF Literature, literature, which is about accessing the abstracts of PubMed and full text of open access articles. And we have an extensive resource catalog and a data federation, and we currently represent a very large source of neuroscience information that you can find in the web. So let me talk a little bit about NIF Standard Ontologies itself, and the idea is the framework through which we have this diverse resources or like from the NIF interface is provided by this ontology, which is standardized ontologies. It represents an extensive collection of terms and concepts from the major domains of neuroscience, and as common with most of the biomedical ontologies, the idea was to assemble the ontologies in a form that can utilize and reuse multiple existing biomedical ontologies as well as standard vocabulary sources. And therefore the overall ontology is also assembled in a form that allows easy extension and modification over the course of evolution. Since the beginning, we have been continually augmenting new strategies to conform with up-to-date tools, trends, and practices, and basically from different recommendations from the semantic web community as well as the biomedical ontology communities. So the NIF standard is actually built in a modular fashion where we have each module cover like a distinct domain of neuroscience, and it includes, for example, anatomy. Then we have cell types, experimental techniques, nervous system function, small molecules, and so forth. And if standard modules are expressed in our description logic formalism that provides a balance between the expressivity and computational desirability, and we can use different RDL reasoners to actually classify ontological consequences. And then we closely follow the above boundary best practices, and but when it comes to community consensus, sometimes we take a practical approach so that our ontologies are always ready for its production systems, and we avoid duplication of efforts by conforming standards like the standard basic ontology and the overall relations ontology and phenotypical qualities ontologies. The whole idea of the upper level ontologies is that since the beginning we have recognized the significance of it. So as the number of ontologies, especially biological ontologies, increases, BFO-like formal ontologies can play an important role to promote semantic interoperability and data integration. And essentially, BFO provides a logical basis to categorize the domain-independent high-level classes, for example, entities, their characteristics and processes. And this kind of characterization helps to avoid ambiguities and erroneous assertions, and it was necessary to develop a large-scale ontology like NIF Standard. And finally, when we assemble NIF Standard, we rely on existing community ontologies as much as possible. And I included this slide just to show that wherever possible, we reuse existing available knowledge sources and terminologies or ontologies. So I don't want to go through details about each and every one of them, but The important point is that the core NIF Standard modules at the right were derived from a variety of sources, and the sources could be fully structured ontologies to loosely structured controlled vocabularies, and they were either adopted or imported as a whole, depending on their state. And the idea, like the ingestion strategy for these sources, is that when an ontology is BFO compliant and we're already represented in OWL, we import the ontology itself, and adapt refers to the sources that requires refactoring of the source vocabularies into OWL and requires normalization under BFO entities. So NIF readily accepts contributions from different. For example, we have included Jessica Turner's cognitive paradigm ontology. It has been imported under the NIF investigation module. And as we work through the process of adopting COCPO, we needed to make sure that the upper level classes in COCPO were BFO compliant and derivable under the same foundational layer of NIF standard. And the properties that were used in COCPO were also derived from the overall relations ontology. So as it is, like the COCPO is part of NIF standard, so COCPO can now be used to annotate datasets for specific querying and comparisons, and contents, all the contents of COCPO are exposed via neural nets, and it can involve communities to add definitions, synonyms, and many other things on top of its core lexicons. And then the idea is that, like at the beginning, we had various different sources with different formats, and we didn't have good translators into OWL, or the community ontologies were not ready for us to adopt directly. So we had different custom ontologies which were basically swapped for the community ontologies. For example, we had the gene ontology cellular component. We had many of the terms, but the gene ontology was in a different format, and then finally, once we had that in our format, we have it directly imported, and we have the semantic mapping between the matching terms that we had before. And so is the idea of adopting PRO and the biological process ontology. So how do we access the NIF standard? Well, it's available in OWL format, and you can load it to Protege 4.1. So we started using 4.1 first instead of 3.1. I think it's easily available to, like, more easy to ontologies through this new version instead of the 3.0 versions, and it supports like all 2 features as well. And we are also available through the NCBO Buyer portal, and we have specific contents that can be specific web services that can be used to like extract specific contents, and I have posted a link here, so you can use these web services to use it in your own applications. And so now let's take a look at some of the design principles that we have adopted. One of the design principles is the single inheritance for named classes, and the idea is that all the asserted classes in NIF standard can only have one named class as its parents. And however, the same named class can be asserted under multiple anonymous classes. And the idea is that this principle promotes the classes to avoid ambiguity and to make sure that the term is univocal within the same hierarchy. And the classes with multiple parents, you can derive them via automated classification of defined classes. And we'll have an example shortly with neuronal types, where we'll see how we use this kind of asserted hierarchy and how do we dive into more more like the inferred classification for the same kind of neuron types through its properties.
I'm glad you're going through the examples, because Gordon just asked if you could see examples.
Yes, we'll have it in about 2 or 3 slides. So this is one of the very important strategies, and I think every ontology should use these strategies. And you can see Alan Rector's normalization principles these strategies. And another one of the other design principles is that we operations ontology for the standard of properties as biomedical communities. And other object properties in NIF standard are mostly derived from them. And the way we have our object properties asserted, like there are 2 kinds of relations. One that are within the same module. That means the intramodule relations, and the other one is about the intermodular relation, with cross-domain relations, and that exists, and we keep them in a separate, isolated module between 2 independent modules. And the idea is that the relations that one don't want to use, they can exclude one of those modules. So the intermediate relations that exist within a module are the universally true statements within a class of a specific module. These relations are kept integrated together within the same module. And the relations between entities that can vary based on a specific application and may require domain-dependent viewpoints, they can be kept in a separate bridging module. A bridging module is a module which is basically a bunch of statements, logical restrictions, and definitions on required set of classes assigned between multiple modules, but it does not necessarily have any of the core terms or classes within it. So here's an example of a bridging module that we have, and we have, for example, the neuron bridge module, which basically is a relationship, asserts relationship between NIF cell, subcell, and NIF anatomy modules. And then we have NIF neurotransmitter group, and we have this neurotransmitters assignments assigned to NIF cell type, and we have this between these 2 modules.
Fahim, do you actually have a bridge file that you can show? Jess is asking for for this?
Yes, we have the links. Let me see.
Can you throw one up
So
really quickly? Or
what you are looking for is okay. Let me see the. Ontology.
all right, but generally speaking, I think we've got so this is the overview, and I think you and others have seen the overview before, but
Do you see
I
the screen now?
your screen.
So is it a different screen?
It is a
So I just
different screen. I see
okay. So
something that says OWL imports RDF source.
yeah. So just for reference to Jessica's question, these are the list of bridging modules that we have, and
Right. So
go to these modules, you'll see a bunch of statements made about neuron, for example, neuron neurotransmitter. And really, that's like it's basically, for example, this one imports NIF and NIF neurons and it starts different restrictions on it. So I'm not sure if that answers your question.
I saying that it looks like an import file and rather than a bridging file.
Well, it imports two different modules at a time. It serves different restrictions as well. Let me just.
And
So
she
I'm
would
not
like
sure.
to see the context. I think.
So let's go to one of.
And Jeff is asking, please move a little closer to the mic. You do kind of trail off, and
Okay, can you hear me now better?
I can hear you now. You're good, but you do trail off just a little tiny bit.
Okay.
At the end.
So Jessica, so like this is basically the OWL statements that we have about neuron and neurotransmitter, and basically the idea is that it's a bunch of statements. It's not really just imports. So you have to import NIF cell and NIF molecule to execute this module to have this process inferred. So does
Can you
that answer your? Yeah.
these and kind of tell us what it's exactly saying? So I see class, NIF cell. Okay, that's the module.
So actually, like I think it's basically our statement which specifying that you have a property that says has neurotransmitter, and it's a subtype of another property which is the transitive property. It is a transitive relation, which is the has molecular constituents, and also let me see the other one. So it declares the object property that are necessary to connect two different modules. That's basically the idea.
Okay, but it's also where you connect classes.
Yes, through a
from different.
yes.
Okay.
So.
All right. So Jess, does that answer your question?
Let me find it.
That helps. Okay. Great.
Yeah, I can discuss with Jessica further, like if she has questions, if she wants to use one of these ontologies, and I can talk with her how to do that with Crochet. I think it'd be more useful than.
So just thought that it might be identifying similarities across the ontologies. And I think that that's another thing that this is supposed to do, right, Fahim?
Yes.
It says class A from ontology A is same as class B in ontology B. Right. So in these bridge modules, and I'm sorry for kind of moving you into some specifics here, but in these bridge modules, what is the best and easiest way to actually assert that a class is somehow related to another class? Mhm. Okay, great. I see a black screen. What should I be seeing? Ah, there it is. Okay, I see the design principles. So we're back to the same uh, slide. So Fahim, you're basically just talking about, or not basically, a very reasonable thing that you've in the NIF standard, but you're going to show the how exactly it is that you assert that one particular neuron could be, essentially have a multiple parent, whereas it's asserted only as a single parent hierarchy.
Where you can have these um, related concepts as well as defined classes.
Right. So,
So
so then bring this back to the cognitive examples that we've seen for the last 4 weeks or so.
yes.
So is the, and maybe you're getting to this, but is the idea that you would actually just have a relatively flat list of all of the different kind of sub-modules. So for example, the tasks, the cognitive paradigms, etc.
Yes.
And then you would actually reason out of those based on their properties that one task is really, you know, possibly can be classified into 3 different kinds of tasks.
Yes.
That would be hierarchy on top of this.
Yeah. Yeah. So yeah,
So,
I'll a little bit about that towards the end. So I think the idea would be the same. Like it's pretty much analogous idea. If we have ontology of all these mental processes and mental functions, if we have sort of defined processes, see the inferred kind of the process that can incorporate. And so I'll go through a little details on that, like what can be done in terms of how do we do that. It basically depends on the community as well. And so in the next slide, to show the that we have a lot of, like a set of defined classes that is useful to infer useful classification of neuron types and molecules. And here's you can have classified by the soma location. You can have them through the neurotransmitter, the circuit role, in terms of morphology and molecular constituents. And we also have classification of molecules and roles, for example, by their molecular roles of drug of abuse and neurotransmitter roles. And so these are all become, so through this kind of classification, the NIF search portal becomes more aware of the concept rather than just a term. So as you type, like, for example, drug of abuse, it would list a bunch of drug of abuse and drugs that are abusive. So that's a very significant feature.
right, so
So the next.
sorry, maybe we can hear from Jana in terms of, you know, she, as far as I understand, her ontology is meant to classify drugs by the various cognitive paradigms that they actually impact or they have some bearing on. Jana, is that the correct way that I'm thinking about to accomplish? And I certainly hope that you can hear us. Okay.
Hello, can you hear me? Anita, can you hear me?
Out.
Should I speak or should I type?
Yeah, go.
Okay, so the only thing that I would add to that would be that it's not only drugs, we're kind of looking at bioinformatics and biological data generally. So we're looking at cross-domain annotations, but each of the annotations would be done with a kind of shared identifier.
One of through yesterday was looking at your ontology that's in BioPortal. Now, I don't know if that's the most up-to-date one, but there didn't seem to be a lot of mappings for the other ontologies. So can you quickly comment on that? Because it would be very powerful if you're doing this kind of a classification, or you have some ways of basically being able to do this. It would be instructive for us to reuse that work. And as we're kind of all trying to do, I think the same thing, which is taking these ontologies and trying to classify the actual data that could, that is being searched and found things. So would you be able to make in terms of the mappings that might exist?
Yeah, they're definitely not released and available yet. I'm kind of in the on these things, so that's why you couldn't find them. No, sorry about that. So what I think, yeah, in terms of time frames, I think that we should start releasing kind of mapping files within the 6 months, but this would have to be, unfortunately, fairly small in scope beginning. And then we'll see, if it's useful for the projects that we identified to start with, which is mainly surrounding oceans, then we'll keep going and we'll keep extending that. We definitely don't want to do anything that anybody else is doing, so I hope we're not trying to do the same thing. I hope we're trying to be complementary in our efforts, because there aren't enough, for ontology work that everybody can redo the same thing.
That's a point. I should have probably said complementary work. So again, I'm trying to think about marrying the mappings in, or mapping to your ontology, because I think something that is highly interesting and to what Fahim is doing here with which he's showing with the molecular roles as well as the various circuit properties for neurons. We'd like to extend that work, but if you already have a
So, yeah. So another question about transmitter role, that is definitely all. So the additional work which we're doing on mental functioning is for things, which never made it anywhere near the biologist normal work of roles for chemicals, but neurotransmitter is definitely a role in KEBI. Are you using that as a kind of source in some way? I hope so.
So I think Anita, sorry.
I haven't seen the neurotransmitter role in KEBI and how that deconvolves into a logical statement, but we're using that as a, I mean, yes, that neurotransmitter role is something that is present in a particular Kebi doesn't have cells, right? So essentially, you can assert that GABA, for example, would have the neurotransmitter role, as would ATP, as would adenosine, as would a whole slew of other things. But what we're doing in standard is trying to say this particular cell releases this cocktail of chemicals, for example, GABA, glutamate, adenosine, what have you, and then that is through this assertion that there is a neurotransmitter is released. So actually, Fahim, the neurotransmitter role being reused from Kebi, or did we actually create our own?
No, it's from Kebi. The role itself is not. Well, the neurotransmitter role is actually something that we derive from the payload. So it's not really. So I have to double check about it. But the actual neurotransmitters, for example, GABA or glutamate, or all these coming from Kebi.
Excellent.
And yeah, so yes. So let me continue with my presentation, and I'll address some of the questions that Anita asked already, and I also have questions about the mental health ontology that Yana has developed or developing. So that's going to be towards the end. But let me introduce the neural X, like what is it capable of, so that the community can engage themselves in a common place. And so the idea of neural X was that it was envisioned as a place where anybody can get in, just like a Wikipedia page, and get involved into content development. And the initial content of the neural X pages were derived from the actual ontology, like the NIF Standard Ontologies, and then later on, like those contents become editable through the neural X forms. And the idea of neural X is that so there are certain distinctions between NIF Standard and neural X. So of course, neural X is not a rigorous ontology, but it has a place within the process of developing ontology. And so I'm just going to show you a little example of the contents, the structure of contents that we have in neural X. And it has a semantic backend to structure its overall knowledge. So a page in neural X can call relevant information from other pages, and so it has the ability to automatically assemble related knowledge about, for example, here the cerebellum, and for example, like here in this box we have neurons in cerebellum, axons in cerebellum, and parts of cerebellum. So all these informations are not necessarily asserted within this page, but may be asserted in some other pages by somebody else, but it becomes automatically populated as a part of a description of a cerebellum. And at the same time, you can see the part of cerebellum, which is basically part of a hierarchy, and this one is also very dynamic. So as soon as somebody asserts a parthonomy restriction to a particular part of a brain as a cerebellum, it becomes available to the part of cerebellum restrictions. So it provides you a structured way of contributing your knowledge into the actual NIF standard contents. And the idea of having this kind of environment is that it allows you to have this bottom-up ontology construction, where NIF standard or our ontologies are mostly top-down approach, and it has only the rigorous relationships or rigorous restrictions, and it does not have a place for partial truth or partial information or anything like that. So neural X kind of is a way where you can have concepts defined in a very uh, like without worrying about any semantic consequence as to if the concept is consistent or if the concept is relevant or not. So that will become available through collaboration of domain experts, and it becomes a place where you start to work through different concepts and find out the relationships first, very loose relation, and then find out the very rigorous relations. So basically the process of conceptualization, not really a process of developing ontology at the, first in the beginning. Like you love developing a very rigorous ontology from the scratch is not easy without, for example, this kind of tools where a collaborative group can work together. So I'm using the same analogy in a different way, and for example, like if we want to have, or let's say we may not have the perfect star at the beginning, or may not know that we wanted a star, um, we have to stumble upon various intermediate steps of shapes and forms before reaching to the conclusion that we have formed a perfect star. So neural X can be a perfect place where domain expert can play around and enrich the entities through those intermediate steps before reaching to a rigorous IL state. Um, and while doing so, we probably have other interesting forms like square and, for example, this class and all these models. So I think the way we see neural X is that it has a place within the process of a very rigorous ontology development. And the next, so I'm just going to talk a little bit about how we see it fit within the neural, in the contribution of within the NIF standard development. So the idea is that neural X is a very curated site that is the members of the project's operators have a way to review the content, and they can modify it if necessary. And the purpose was to have the communities get involved and contribute to things like definitions, synonyms, or more relationships. And the contents then become available for contribution within the NIF standard, and that those contributions are
Okay, Fahim, we're actually starting to run out of time. Is there can we actually start to address some of the specific? Okay, thank you, Fahim. So Jenna was adding, we are actually having this workshop the day before July 22nd, the day before the ICBO, so that we can actually and work on all of these issues. I think that this generally, this has been very useful in terms of learning what the different groups are actually doing, a little bit about what what the perspective that they're coming from and what they would like to see. So Jana in the chat box has added the link to the ICBO meeting, the additional workshop. So I think that Fahim, you'll be there from our group. I'm still not sure. I haven't heard back in terms of whether I will be able to. But the idea with mental functioning is, how far can reuse actually go? So Jess, since I can't get to the workshop, I would like to have a call discussing these points. I agree, and that's so Jess is also saying that another one of these discussions would be very good. And I think I agree with you, Jess, because we haven't really gotten to the meat. We've sort of gone through this, this is what everyone is doing, this is how everyone is actually seeking to incorporate other people's work, but we haven't actually gotten to a lot of the nitty-gritty. In terms of, what are the main points of contention between the various ontologies, and then how do we address those? How is it exactly that we're going to need to address those? So, and just you're typing, so I'm going to wait until you finish typing. Okay, here we go. Maybe a focus call on how we link people's working memory process across these ontologies. I think that would be a really good idea, Jess. So maybe I'll set up a less formal thing, perhaps at the same time in the next couple of weeks to make sure that we get more feedback from Gwen, and I'm hoping Jana and anyone else that actually has an ontology or wants to have an ontology of mental function, so that we can come out of this with sort of a unified, this is what we're going to do. So, and I think that this, our time is just about expired. So if anyone, or does Jana only have emotions? Okay, so Jana is saying that she agrees, but I think she has much more than just emotions. I think Jana has some too. Ha! Sorry, apologies. All right, so in any case, what I'd like to do is, again, I'll be in touch with, I'll be in touch with everybody in terms of how to get some of these points together. If anyone else has any quick questions or lengthy questions, I think we could probably take one before everyone runs off to their next meeting. But I will be in touch in terms of a further wrap up and a synchronization of a lot of these efforts, because I think this is, where we're starting to get to a point now where we're really, I think, going to be able to accomplish something significant in the next round. So, and we may need to do that kind of a distributed email list, but I would love to actually bring this to a focus in the next few months, and then the real focus, I think, will be the workshop. Okay, so Fahim, thank you very much again for doing this talk. I don't see any other questions. So, so we will reconvene on the NeuralX mailing list and others, and you are getting applause. So, and thank you all very much. So Fahim, I think that the half an hour webinar is a myth. That's my my thinking at this point, because it's never goes a half an hour, no matter what, and that's my blabbing aside. So, all right. So Sridevi, is there a question? Okay, she's just saying thank you.
Alrighty, everybody. Thank you very much for participating. And again, we'll be in touch over email. And